Hello and welcome to the latest instalment of the TMG webinar series. Today I'm absolutely delighted to be joined by Graeme Thomas from Engineering Technology Group. Graeme is going to spin us through sort of 20-25 minutes on the benefits of 5-axis machining, which I'm thoroughly looking forward to. But before we get to you, Graeme, I'm just going to spend a couple of minutes just reminding everybody about who the TMG are and the benefits of being a member. So if I just share my screen. So Training and Manufacturing Group is a consortium of like-minded companies, and there are over 150 businesses within the group, and we exist to support their sales strategies and other strategies that they have through hyperlocal collaboration. We're a not-for-profit organisation, and we just exist purely to improve the performance of the members. We're very lucky that we're supported by our technical partners, Incom Training Services, BDO, Goering, Hexagon, FBC Manby Bowdler, Boramat, who were last time's edition of the webinar, and Engineering Technology Group. The benefits of becoming a member, so you do get regular content and information from the technical partners. You get the chance to attend informative briefings. You get a free legal review of your business, discounts on more than 100 courses with Incom, access to some grants and funding opportunities, support with apprenticeship recruitment, seminar program, and the all-important, the jewel in the crown, I think, which is the access to prototyping capability and access to experts like Graeme. So on that note, Graeme, great to have you with us today. We were just talking about the fact that you're in Wellesbourne today and you're in a COVID secure environment and that you've been fairly busy.
Yes, Neil. Yeah, you know, we've been working hard here to be able to get the facility set up, because we still have customers that are still looking at various projects and machine tools, and believe it or not, we've had quite a nice range of visitors since we came out of the lockdown back in sort of end of June. And that's sort of related to people starting to relook at what their planning for 2021 is. So yeah, we're pleased. We've got a great facility here, and we're very pleased to show it off. And unfortunately, we haven't been able to do that as much as we would have liked to in 2020. But we're looking forward to hopefully a good and secure and you know, to have some further events here in 2021.
Yeah, your open house was brilliantly received last time out.
Yeah.
Right. I'm going to hand over to you to talk us through 5-axis machining and the benefits of it.
Okay. Thank you very much, Neil. Okay. Right. Okay. So thank you, Neil. Thank you for that introduction. As I say, Engineering Technology Group are proud members of TMG, and we obviously want to take a very active approach with the membership. So basically, I just wanted to give you all a bit of an overview of what ETG actually is and what my role is. So as Graeme Thomas, I'm the Group Business Development Director for ETG, and involved in obviously what our total business strategy is moving forward and where we want to make our connections for the future. So just to give you a bit of an overview, Engineering Technology Group, our motto is making engineers champions, and that's from the small SME groups right the way up to our OME manufacturers as well. We were first established back in 1996. When I first joined the company, it was Chiron Verka UK Limited, working out of Leamington, and that was effectively our roots, and we've morphed into a massive group as we are now. The great pride in that we are still a privately owned and independent company as a machine tool supplier in the UK. That is very, very rare, and we're very, very proud of that as it stands. ETG works across 3 sites based in the UK and Ireland. And under those particular sites, we can offer the largest range of machine tools available to us, including milling and turning machines. Now we have wire EDM machines. We're active in the additive manufacturing markets as well, balancing machines for gearbox technology and drivetrains, microfinishing, gear grinding, and subcontract laser marking that we can offer here in Wellesbourne as well, which is quite interesting to some companies based in the Midlands. So the key sectors of markets that we actually worked into, we're very active in the aerospace market, but obviously due to the pandemic this year, that's took a major hit on airframe and Airbus manufacturing in the UK, as we know through our customer base. But certainly through the medical, defence, energy, and automotive, which is starting to come back, certainly in the electrical vehicle market as well, has kept us very, very busy in looking at future projects around our machine tools moving forward. So our three sites, we have our head office where I'm based out of here in Wellesbourne, which is close to Stratford upon Avon. And that is where our head office is actually based. This is where we have a fantastic state-of-the-art showroom here as well, with the ability to be able to show our machines off and premium brands to their best. And it's where we also run our service and spares and support business from here as well. And all of our technical engineering is also based here in Wellesbourne. We do have a manufacturing facility as well, based over at Highfor in Coventry, where we can manufacture all of our own bespoke hydraulic and pneumatic fixtures for a majority of our turnkeys, along with a very good other customer base that want to supply fixtures directly into their production. And then to open up a few avenues with our medical business over in Ireland, we have a facility in Newbridge, which is just outside of Dublin, as well in County Kildare. We also have a nice showroom facility there, training that we can actually offer on the machines, and service and support for the Irish and Northern Irish market. So as a machine tool provider, I mean, we've got some fantastic brands in our portfolio. A few which become sort of household names of anybody who's spent any time in engineering or done their apprenticeship through the Bridgeport Hardinge range of machines. Chiron on medium and high volume products. Nakamura has a Japanese product on multitasking machines, and Quasar from Taiwan, along with Pietra Kanagi, which are very big in the nuclear industry and aerospace industry, and all Rolls-Royce Trent engines have all of the main containment cases and rings made on Pietra Kanagi machines flying around the world every day. Under EDM, we have Mitsubishi Electric. In the additive sections, we represent Markforged and 3D Systems. And we're also pleased to announce this year, unfortunately during the middle of the pandemic, was a new brand called Vulcan, which is ETG's own brand of machine tools, which are lower cost lathes and machining centres for a lot of startup businesses in the Midlands have actually really bought into that product at the moment, because it's a fantastic value. And we're finding that those machines are outperforming their price level. So could be some interesting things there for some of the TMG membership to talk to us about on that level as well. And importantly, to be able to run and work these products as well, the sort of software systems and keeping up to date with all of the technical changes in that area, we have all of the top brands that we actually work in and produce and sell to our customers as part of turnkey projects. So a very large offering that we have here. So just a bit of an overview against the particular products there, just some imagery to ignite a few ideas on what they can actually do. As I say, Chiron is in sort of medium high volume, predominantly automotive based, but we've got big roots now into the aerospace market with their product. Nakamura on multitasking, multi-spindle, multi-turret machines. So anybody in the sort of high volume, mid volume turning market is very big under Nakamura. And then we go up to the Bavius range, which obviously on airframe, rib components for Airbus and Boeing in the UK, very big in that particular market. And as I say, some of the pictures that you can see below, one of the Pietra Kanagi machine there, you can see on a 10-metre table diameter, which you can just see that little white figure is a man actually standing in the centre of that. So that gives you some idea of scale when it comes to those type of products. A new, over 2 years ago, Engineering Technology Group bought HK Technologies and actually brought their business in to enhance our portfolio even further. And under those particular brands, we've got the Mitsubishi Electric, which is proving to be a very, very good seller for us in the UK and Ireland at the moment. That's moving very, very well. OPS Ingersoll, which is high-speed graphite machining for the die sinking industry, and right the way through to Cap Niles on gears, 3D additive and Mark Forge 3Ds to allow us to print in metal and polymers and composites. So gives us some very, very good opportunities there. And then micro finish machining on highly performing components in gearboxes. So how we see ourselves at ETG, we see ourselves as a turnkey solution provider to our customer base. And what we obviously offer to our potential customers is evaluation. It's when somebody's looking to do process improvements, some changes to their particular product. We can actually come in under a sort of consultancy basis there and actually look at how we can actually increase profitability, productivity, and obviously come up with better manufacturing solutions for a customer. So evaluation is very, very big for us. And then the capability is around our engineers coming up with the best process improvement, machine tool, work holding, etc. And once we've developed that and we actually take orders on this, the most important thing is the aftercare. And we use the term cradle to grave in our portfolio, and that's looking at from a point of enhancing an initial concept into a long-term 10-year, 20-year investment with ETG to keep that machine tool in production. So we've got a very strong base of aftercare engineers working on that base all the way around the UK and Ireland. We have the ability to design in-house as well, so we've got very good capability there to be able to design our fixtures and ideas and implement them through our own design house in High4. And then implementing that for the customer. The most important thing through training and development of this level of technology, we've got to have the engineers that are up to speed to be able to make sure that the customer can really get the best out of that particular product and solution. But then when we come to another important factor as a business is the technical support. So we obviously can develop turnkey solutions and design and implement how to be able to take a component when somebody comes and challenges us to how can I produce this in the best way. We get involved in that. Training and development and recruitment is a big part of our business, and through our membership of TMG, we're also a very big supplier into the training academies through Incom, who run a lot of our machine tools. And we're pleased to say that the apprentices and engineers of tomorrow are being trained and using our equipment to be able to move them forward and understand the sort of latest technologies that we can actually offer in those training academies. Process productivity improvement, very, very important for us to be able to make sure that customers are getting the best margins and profitability from their components. And one other thing that we spend a lot of time, because of the values involved in some of our products, return on investment studies, is everybody is very quick to say, oh, I can't afford that. I don't know how I'm going to be able to get the finance to put that together. Through all of our contacts within the group, we can sit down with customers, quite easily work out that actually spending that money, what the return on investment could actually mean to their business. But also as part of that, be able to work out what funding we can actually bring to the table as well, through various connections that we have, to be able to say, well, actually, with this level of funding, these grants, and this way of looking at how you're actually going to get a return on your investment, it makes that as a very, very sound result in investing in ETG and our products. So that's a bit of a brief overview of what we do as a company. So obviously the next part is to move into an introduction to 5-axis machining, which is what we're talking about today. So initially, where we start off, first thing is to understand what the configurations are when we talk about 5-axis machining. And the first configuration is what we call 3+2. And what that actually means is it's taking a standard 3-axis VMC that most small SME starter businesses would actually probably invest in, but may want to move forward with that. And then obviously we would have to then add a 2-axis rotary table to the main table of the machine. But what a 3+2 means is we can actually simultaneously program in 3 axes, which in this particular way is normally X, Y, and Z. And we can independently position the rotary in an A and C axis. So that doesn't give us the capability to sculpture or mold components, but it gives you a lot of advantages when you may be drilling at certain angles or being able to machine flats but rotate the part around much easier in one clamping. So that's probably the base of where you would actually start from in any form of 5-axis machining. And it normally means that that's a cost price machine with potentially a lower spec control to be able to drive that, that table and the machine around. And the next configuration is what's called 4+1. So the 4+1 is also then possibly taking another standard VMC and adding a further 2-axis rotary table to the main table and bed of the machine. But it means that the control is probably a higher spec, or what we would call a mid-spec controller, where you can actually program 4-axis simultaneously. So we can actually potentially move the machine and the table through X, Y, Z, C, potentially A. And we could actually move to fixed point in 4-axis. But then we'd have to use the other further axis of the rotary table and position that independently, because the control doesn't have the function to be able to move all axes together. So those are the 2 sort of starter points that most people go into when they start to adopt 5-axis machining. Next stage is when we start to go into what we term as full 5-axis. So what a full 5-axis machine actually means, that is where you start to get an integrated 2-axis rotary table is built in and configured as part of the machine tool construction, as seen in the picture there, where the A and C axis is actually part of the main frame of the machine, and that's what's called a trunnion type table, and that's actually how that is configured. Now, what it means is with this machine is that we can actually simultaneously program all of the axes together, which obviously gives the fastest point-to-point positioning that you can get in any 5-axis machine. It gives us the ability to obviously sculpt and 3D mold components as well. So actually we can actually form some very intricate components, and we've done various things where we've modeled Darth Vader's head and various other things as little giveaways on stands where customers get quite intrigued, and we did a Jaguar XJS as well for a particular customer that was quite interested in Jaguar. So we've done various bits like that, but that's taking it right the way through to a modelling spec. So as I say, that's all axis positioning. It normally requires a very high spec control, and the best for this type of machine for 5-axis is normally FANUC 31IMBs, the Siemens 840D solution line, and the Heidenhain TNC 640. These are the sort of latest CNC controls that have the highest power for being able to control these machines and get the ability to be able to do those parts. The other high factor there is you've got to have a machine that is really capable of taking high dynamics, because the reversal of directions is very fast, high acceleration rates. Therefore, the machine has got to be very stable to be able to take that level of dynamic movements. And then when it comes to components, when you're actually getting the most accurate component that you possibly can, because of the level of the control now, we run programs which are called kinematic controlled programs, and normally Cycle 800 is one that we run quite constantly, and with a probe in a spindle, we are able to check certain dimensions around a particular component, run the kinematic cycle, and that would then, through parameter change, be adapting and looking at the control to see if there is any particular movements within the machine that need to be dampened out and controlled more accurately. So by running those programs, we can definitely quantify the quality of the component. So when we take it from one step further, is obviously under our offering, we can go to what's effectively a full 6-axis mill turn, which is one step further. She's taking the full 5-axis machine, but being able to mill turn as well. So where you have a C-axis table that obviously can rotate around to get to certain positions, the C-axis now becomes a full turning spindle as well. So we can claim that as an extra axis and be able to mill turn components on a 5-axis machine. So that's normally through our sort of Starmer and Chiron configurations. At that level and top end of the market, we can actually give those offerings to customers, making very, very precise, very, very complex components as well. So again, that's another part of the market that we can actually lead in quite easily. And then we look at some other configurations and different changes that we can actually have all set around 5-axis, where this is an AB axis configuration. And that's where the actual table is not on a trunnion, but it's actually driven from one side, but very, very made for dynamics and very, very small components. And the sort of typical markets we work in with that configuration is the sort of jewellery, watchmaking, medical sector markets that like a very, very small compact machine. They have very, very small cubes, probably 250 to 300 cubes maximum. And that's the sort of areas that we work in with that type of configuration, and very highly dynamic. But then we come into customers that run very sort of long, thin type style components as well, but require 5-axis machining. And this again is still AB because the head is rotating around the X-axis. But we're able to rotate, as seen here with a rib on an aircraft on a cube, is rotating around an A-axis. So it gives us another ability to tilt a very long, thin component around inside a long bed 5-axis machine. And we go to another configuration as well, which is called an AC axis. And this is normally where the aerospace sector come into its own, where they make very, very large airframe rib components from very big aluminium billets. And to be able to load those components, we load them onto a table, which then folds up into the machine. So we actually machine that in a horizontal approach rather than vertical. But the head arrangement is rotating around on the C-axis and an A-axis, which is on a tilt. But it actually gives a very, very good free flow of aluminium swarf chips straight into the bed of the machine. And a very high dynamic, very high productivity and very high metal removal rates on those components. So they are other configurations of how we can adapt our 5-axis approach. So here, this is to be able to show the dynamics of how a machine actually has got to be able to react to the changes of directions. I've got a small video here which actually shows a Chiron FZ16 producing a section off of a 5-axis Blisk machine, and that means a bladed disc, which is very big into aero engine design components. But as we go in and watch the video, you can actually see that undergoing change of direction is very, very quick. And the machine has to cope with very, very high levels of yaw rates and what we call jerk to be able to keep a constant cutting speed on the tip of the tool. And believe me, none of this is speeded up for visual effect. This is all cut in real time. But it shows the dynamics required within the machine tool to be able to cope with that level of accuracy and quality. Yeah, so as you can see, the dynamics of that machine is very, very high. So once we've actually chosen our machine tool, we've got the right configuration, we know what the application actually is, and we've sat down with the customer and worked out what is the best machine tool to invest in. The next stage of that is looking at effectively what is the best way of actually holding the component. So the 5-axis work holding plays a big part in understanding exactly how we want to be able to manufacture it. So another part of our work holding business is that we can offer Spritzer self-centering vices, which actually sit on the actual table of the machine, but gives us the ability to block load a component, and by tightening the actual vice up, it actually moves in both directions, gets the part completely centered on the machine itself. So what that actually means is we get very high clamping forces off of a very low edge of the component, So potentially probably 3 millimeters maximum on the base of the material, but we can actually have a very, very high gripping force on that part to be able to move it and be able to withstand very high cutting forces. The great thing about this particular device as well, it's a centric spindle bearing. So obviously from a point of view of thermal growth and expansion through the machine and through the part, all of that is relative to the centre line. So we don't actually lose any accuracy in the component as we move forward while we're machining it. Very high structural rigidity in these particular vices designed for this particular application. And as you can see, the vice jaw is pretty much the full width of the actual base there. So it's got optimal guideways there to actually give us the best clamping forces and absorption of cutting forces into the vice itself. And the most important thing on these type of vices as well is to give greater tool accessibility as we move the tool and the head around the component. So we normally need lots of access areas to be able to do that. So then the next thing, we've got the work holding set up. The next thing is to obviously look at typical tool holders that are used in 5-axis manufacturing. And as we've seen in the picture there, high-speed precision collet chucks, which are manually locking the tool device back into a collet, which then is locked back through the back of the pull stud with a key. So we're actually pulling the tool back into the collet, which obviously can take very, very high dynamic forces and side loads for milling. We have another offering is hydraulic collet chucks. This is where obviously the tightening of the tool into the actual holder itself is actually deforming the inside of the actual body there under hydraulic load. And that's what's actually locking the tool back into that particular holder as well. And using hydraulics on there can have quite a good dampening effect to high side loads when doing very heavy milling operations. So there's some major advantages in that particular area as well. Shrink fit holders. This is another holder where you tend to buy a separate unit, and we do quite a lot of work with a company called Heimer that is very big in this particular area. What it means is that the body of the actual tool holder itself is heated. So obviously we get an expansion of the tool body, which allows us to insert the carbide tool into the holder quite freely. And then we quickly cool the body down, and obviously that cooling of the actual body actually works as a lock around the shank of the carbide tool. So that then actually becomes part of the tool holder itself, which is a real positive way of actually holding the tool in that particular tool holder. And again, that configuration is very good where we may be doing very deep pocketing in a particular component where we may have some movement in the tool because we're actually doing very, very high pockets. The tool can actually be pulled out of the holder slightly, which obviously then can decrease the amount of reliability and accuracy in the component. So there's benefits of all of the 3 main tool holders that we use, but it's specific to applications. And obviously our engineers would obviously always support the customer with the best tool holder for that particular application. And again, as you can see by design, most of these are tapered or what we call pencil holders as well, which means that they're very, very small diameters there. And again, that sort of really aids to the machining properties and giving us optimal accessibility to get us close to the part as we move the part around the tool and the cutting edge as we move into the machining process. So we're now starting to move through the whole process. So we've now got our machine tool, the work holding sorted, and now the tooling packages. So the next thing is how are we actually going to develop and write the programs for producing the parts in 5-axis? So under the programming packages, we work very, very closely with Mastercam, which gives us the ability, and Hypermill now, as well as another offering that we have within the business, is to look at a particular customer's components. Majority of customers now actually can generate 3D models of the actual components they want to manufacture. And with a certain CAM packages, we can actually take the 3D model and images and data from that model, which then goes into another package through Mastercam, and that then generates effectively the code. So when we have the programming code, that takes the code, which we then upload to the machine's control through a post-processor. And that would then take all of that data into a machine code to be able to replicate that 3D model and be able to produce that part on the machine table. So there's quite a few processes that it would actually take to actually get to a finished part within a 5-axis machine. So here, to be able to show some of the impacts, so we've gone right the way through this process. This was for a particular customer that makes turbo impellers for the diesel market. And obviously the numbers of the impellers and the volume is very, very high, which obviously probably will be impacted by the electric vehicles coming through in possibly the next 10 years. But at the moment, it's still very, very high volume. And obviously the ability to be able to take a 3D model, look at the generation of how we actually hold the tool, the work holding, and be able to generate the part. This actually shows the next step forward was, because of the high volume, is how we can actually synchronize two parts and make them simultaneously in one platform of a machine to be able to get the takt time and throughput and productivity much, much higher. So this little video now shows effectively a Chiron DZ08, which means a double spindle machine. And this is a program and a project that we worked on to be able to develop a process for a customer. This is the smallest platform of footprint and productivity machine that we actually have on the market, which has got some great potential from our customers on when they're trying to save floor space to productivity, which has a cost and a saving for the customer. Okay, so now that we've got a whole process, we've been able to take an application, we've developed the machine tool that's required and got right the way through from a model to a program. So then when we're trying to sell it back to people that are thinking about, do I want to move into 5-axis machine? What's the real benefits to me? What's it actually going to hold for us? So to sort of finish off the presentation, I just want to go through what we always explain to the customer on what the benefits of 5-axis machining could be for you and your business is effectively the ability to machine complex shapes in one single setup. And normally the advantage of that is you can see the components sitting there on a table. There's lots and lots of features that are being machined in that particular component there. And that would normally probably go through 4 or 5 different operations if that was done on a 3-axis vertical milling machine. And obviously every time the operator has to move the particular part around, that's lost time. And effectively that's time that the customer can't get back. So there's obviously an advantage to be able to do that in one single clamping and save particular time, get the machine to do all of the operations in one and be able to take the part finished off the table. So normally, as I say, with a lot of dead time that gets put into an operator having to stand in front of a machine, move the part around from vice to be able to split the operations, the 5-axis benefit is obviously higher machining productivity, because once he's loaded the billet into the machine, they can actually shut the door, walk away. The run time may be actually individually longer by operations, but overall it means there's had to be no manual intervention in that process whatsoever. So, you know, it really does actually add to the amount of components that you can actually get through the machine at any one particular point. And obviously the one other element which starts to creep in, when we actually split operations and we have to go into 4 or 5 ops to be able to do the parts we can do on a 5-axis machine, there is always more possibilities to add errors and alignment issues into the part, because every time we have to pick the part up, rotate it, move it, we actually are putting in potential possible errors. We have to then recheck a particular datum point, and we have to make sure that we're actually coming back to exactly the same point every time. And then when we actually finish the component and then take that to a CMM check, we can actually find that actually the second or third operations have actually moved out and are not tied to the first operation. So 5-axis machining in one op has one major advantage there, that we only have to set the datum once. And from that datum, all of the features of that particular component is all set around the center point of that component. So that's one other major advantage to a lot of customers when they're looking at quality of parts. The other major cost saving is on the work holding itself, because when you do split multiple operations, you're either going to have multiple vices, multiple setups, bespoke fixtures. It takes more time to set up the table, and it takes more operating time. And obviously, the more time you're spending with the doors open on any machine tool, the spindle's not turning and it's not actually earning you any money. So that's the important factor to say, well, actually, I've got about probably one vice on here where I probably have to buy 4 or 5 different setups to be able to clamp the part. This has a major saving overall on basically how I'm going to clamp and hold the part. Another major advantage on 5-axis machining is because of the nature and how we're moving the part around to the cutting edge of the tool. We're able to really reduce the tool lengths down quite dramatically, because we can actually move through all the angles and not having to reach over a fixture or get down the side of a part. So we can keep the tool lengths very, very short. And obviously the advantage of that is that can reduce vibration in the cutting edge and the tool, which obviously has a major factor when it comes to tool wear as well. And obviously we can lengthen the tool lifetime of that particular tool. There's a major cost saving in tool wear and tool life. And vibration normally means surface finish issues and quality issues as well. So all of that starts to come back to you when we can try and keep the tool lengths as short as possible, and that's another key factor when we're setting up tooling for 5-axis. Obviously, the other major benefit in the way that we can actually do things is machining components completely from a solid block. And obviously, as we can get all the way around there on 5 sides, we can also then finish the base of some components where we may actually add additional material to the base of the part. It actually means we can machine a complete component from a full block and actually leave the waste material actually in the jaws of the 5-axis vise, but actually produce what we call a tang, which is effectively where the component is actually then able to move and flex within the last remnant of the material. And what that means is when the program is finished, we may have 0.1 of a millimeter left on a very, very small lip at the base of the part. And when the operator then opens the door to go in there, can literally take the part, tilt it through 90 degrees, and then snap the part actually off, leaving the material in the vise, but actually taking the part literally out as a whole component. And obviously that has a major advantage as well in the way that you haven't actually added any influence into the part regarding the clamping forces of the component, and it comes out as a very, very good, accurate, nice part. So again, another major advantage when machining in 5-axis. And then overall, the sort of main benefit of all of this is trying to give the customer the lowest cost per part. Because everybody is chasing every last pound as they possibly can. And when they're looking at investments and returns, effectively the higher margin and profitability that we can get out of the components that we actually manufacture, obviously that's a major benefit at this particular time when everybody needs to be increasing their margins as much as possible. So every solution we look at is all based upon how we can actually achieve the lowest cost of production per part for that particular customer. And that's going to be major. And certainly with Brexit and things coming up at the moment, and the pandemic, we've got customers now looking to try and return components back to the UK so that they don't have to worry about losing parts coming in from abroad. And Brexit, I'm sure, will have an influence on how people see how they actually need to get their profitability moving forward. So we look forward to talking to a lot of customers about their manufacturing moving forward into 2021. So I hope that was just a brief introduction of what 5-axis can do, what the configurations are, and how we hope to be able to help the membership of TMG moving forward on anything that they would like to throw at us. So thank you for your time.
Brilliant. Thank you, Graeme. Very informative. If a company wants to move into 5-axis, what do they need to think about in terms of hardware? What are the key?
Well, I think normally what we see is smaller startup businesses and SMEs have normally probably bought a lower cost 3-axis VMC is normally probably the starting point, as I say, and normally when they can start to see what the advantages and benefits of 5-axis could be for them, the sort of first consideration is obviously looking at the hardware requirements on a machine tool. So normally if somebody comes to us and say, we've got a machine tool, we want to try and move into 5-axis, what do we need to do to get the machine tool up and running? So the first thing we would have a look at is the control data. So the first thing we would ask the customer is, what is the machine? What is the control? So the control would certainly give us an indication of what it is, what tables we could put on, how many axes we can actually drive with it. So once we know what the control is, the next step is then most machine tool manufacturers leave what they call in the electrical cabinet spare drive card positions. So once we know that we can actually put a 5-axis table on the machine, we would then look for compatibility for fitting a drive card, which is a piece of hardware which needs to go into the machine control, which actually gives access to the PLC to be able to drive the table from the main control. Then we'd obviously have to look at integrating the cables through the cabin. So as part of a retrofit package, our engineers would come and do that, fit the cards, do the retrofit on the cabin to be able to take the cables. And then the next thing is obviously looking at where we actually position the table and the size of the table, because a lot of people have to take into account that normally when a table rotates up through 90 degrees, depending on what the Z-axis stroke is, you actually get a very, very small amount of distance for tools and components. So we would also consult with the customer to say, actually, within the size of the machine tool, you could only actually have this size table to be able to move forward. And that's something our engineers do on a daily basis. So we're taking those calls all the time now.
Brilliant. And the sort of advice that ETG offer to TMG members, how does that work? How do they get about tapping into your expertise?
Yeah, I think obviously trying to engage more with the TMG membership and trying to get some of the businesses to engage with us. I mean, we would offer a free of charge service to the membership to obviously come and make an assessment on what they're actually doing. If they're trying to move on and do some process improvement, and again, as I say, a lot of businesses are trying to see through process improvement, can I increase my profitability on the amount of components and parts that I'm doing? And through our application engineering department, we would get one of the guys to come out, sit down with their engineers, understand what their particular issues are in their production at the moment. And obviously we would do that on a basis of coming in and saying, well, actually, have you considered this work holding, this part in this particular orientation, and work holding and tooling solutions would be able to get that part through in the higher quality. Yeah, we'd love to be able to send engineers in to be able to do that as a little bit of service for the membership.
Brilliant. Thank you. Graeme, fascinating 45 minutes. Thank you very much for your time. Have a fantastic Christmas and Merry Christmas to all the TMG members.
Yeah, thank you very much, Neil. And thank you very much for inviting me to come on and talk to you today. So yeah, let's hope we get some nice feedback, and the same to you. Have a great Christmas, and we look forward to seeing you all safely, hopefully, in the new year.